This video is going to walk you through a problem using stoichiometry. When tackling stoichiometry problems, I first start with annotating the problem. So the problem reads, how many moles of oxygen are needed to produce 640 grams of iron 3 oxide? My given, I'm going to underline, is 640 grams of iron 3 oxide, and I'm trying to find moles of oxygen. So this is going to give me this is my starting point, and this is my end point. Okay, that's the first step. The second step would be to balance the equation. And this is a pretty tricky one to balance. We've got the elements iron, sulfur, and oxygen. On the reactant side, I've got 1 atom of iron, 1 of sulfur, and 2 of oxygen. On the product side, I've got 2 moles of iron, 1 mole of sulfur, and oxygen's tricky. It's split up into 2 different places, so I have 5. Okay. Before I start balancing it, I want you to look at this side. Oxygen is only here, and there's 2 of them. So I can only have an even number on this side, which means I must have an even number on this side, okay? Since this is 3, anything added to an odd number is going to give you an odd number. So I know that I have to put a 2 in front of there to make that 6. Okay, so now I'm going to change this to 8. And this will change this to 4. So I make that correction at the very start before I even begin. Okay, so now I need to balance iron on this side. I'm going to put a 4 in front of there. That changes iron to 4, and it changes sulfur to 4. I need 4 sulfur on the product side, so I'm going to put a 4 in front of this. That changes sulfur to 4, changes that number of oxygens to 8. So I have 8 plus 6 gives me 14, which is an even number. Okay, to get 14 over here, I would multiply 7 by 2, and that will give me 14. So now I am balanced. The third step is we need to find, since we're looking at oxygen, and we need to find the molar mass of iron 3 oxide and oxygen. So if I look here on my periodic table, there's iron. So if I'm going to do iron 3 oxide, I've got 2 moles of iron, 3 moles of oxygen. My molar mass for iron is 55.8. We'll just round it to the 10th place. And oxygen is going to be 16. So when I multiply 2 times 55.8, I get 111.6, and 3 times 16 gives me 48. Add those 2 together, and you should get 159.6. Okay. The molar mass for oxygen is going to be 32. So now I have my molar masses for. So now if I go back to my problem, when I balanced it, I had 4, 7, 2, and 4. Okay. This is my given, and this is what I'm solving for. The molar mass Molar mass for iron 3 oxide, or molar mass for oxygen was 32 grams per mole. And the molar mass for iron 3 oxide was 159.6 grams per mole. Okay, so now we're going to start setting up our problem. You always start with your given. And each section of the stoichiometric fence should have a number, a unit, and a substance. So every part of every fraction should have all of that. That's my given, okay? We're going to take everything except for the number and bring that down to the denominator, because that's what we want to convert from. All right. If we're converting from grams, we first need to get into our conversion unit, which is moles, so that we can do a mole-to-mole comparison. And again, I'm going to take those units and bring them down, because I want to convert from moles. Okay. And since I'm looking for moles of oxygen, here's where I'm going to do my mole-to-mole conversion. Notice I haven't put any numbers in at this point, okay? If you have grams over moles, where you're going to get the numbers is from your molar masses. Okay? If you have mole over mole, you're going to find that from your balanced equation. So if I look at here, I know that if I have 1 mole of iron 3 oxide, it's 159.6 grams. Okay. For my balanced equation, I have a 7 in front of the oxygen, and I have a 2 in front of iron 3 oxide. The reason we set it up this way is these units, because they're in the numerator and the denominator, will cancel out. We'll be left with what we're solving for. So now we do the math. Up top we've got 640 multiplied by 1 multiplied by 7. And when you do that, you should get 640 times 7 gives you 4480 on top. And on the bottom, we're going to divide that by 159.6 times 2. And that gives you 319.2. So we're going to simplify that into a whole number. Do the division. Since we have 3 significant figures there, we're going to round to 3 significant figures. We would have 14.0 moles of oxygen. So hopefully that helps.